Hi, my name is Kenny Nguyen, and this is my second project on chapter 13. And for the learning objective, we have compare and contrast the various dyslexias: surface, phonological, direct, and developmental, as well as the dysgraphias such as phonological and orthographic. So to start off, we're going to start with dyslexia. And dyslexia basically means faulty reading, and you can acquire dyslexia via brain damage, and these include surface, phonological, and direct. And then you also have developmental dyslexia, which is reading disorders that appear to be genetic and become apparent when a child is learning to read. So it runs in the family, basically. So first, we need to understand how we read words. So when we see a word, we either know the word and just say it, like for example this word is just no, or we don't recognize the word, but we understand how it is pronounced, like the letters are pronounced, and we sound out the letters so we can say the word. So for example, I'm assuming most of you don't know Russian, but I've told you here how you can pronounce these words. Like the letter H is pronounced N, and then E is Y, T is T. So if you were to sound this out, it would be Niet. Alright, now let's talk about surface dyslexia. People with this disorder have trouble with whole word recognition of certain words, but are still able to sound the words out loud. So basically, they have trouble visualizing the word correctly as it is. For example, they might read the words pint and yacht as pint and yacht, but they can still recognize the letters and sound it out, so they can say out the word to help them read it. But this can make it easy to misinterpret words or sentences. As you can see, for example, if you were to see this by itself, you'd be like, what is that? But if the whole sentence says, I need a pint of beer, then you'd understand it. Let's move on to phonological dyslexia. It's the opposite of surface dyslexia. They can recognize words, but they struggle with sounding out new words. So recognize a word, can say it, but if they don't recognize it, they really struggle with trying to sound out the words. So they need to already know what the word sounds like, and this makes it very hard to read words that they haven't seen before or pronounceable non-words. Alright, and as I said before, the brain has been affected, and that is why they're struggling to read the words properly. And the book mentioned something very interesting about how Japanese had two separate writing systems. Technically they have three, but let's not get into that for now. But so here we have kanji. It doesn't tell you how to pronounce it. It's just a symbol basically. And so this, for example, says Dewa, which is the current era of Japan. And then this is how you pronounce konnichiwa. So it tells you how to specifically say it. So this basically showed us that there is two separate areas of the brain that works on pronouncing and reading words. And for word recognition, we have the visual word form area. And if this is damaged, obviously, you would have trouble reading the word and recognizing it. And for phonological reading, like sounding it out, if you have damage in between the areas of the inferior frontal cortex or in the temporal parietal cortex, as well as the area between that and the posterior inferior temporal cortex, you would have trouble sounding out new words. Now let's talk about direct dyslexia. People with direct dyslexia are able to read, but they won't understand what they're reading. For example, Litton and Brust, they had a patient who had a stroke that damaged his left frontal and temporal lobes, and he was shown a list of words and a set of pictures. He could read the words, but he couldn't identify what picture the words went with. Developmental dyslexia. As I mentioned before, this is genetic and can run in the family. The concordance rate basically means the rate at which people with the same genes will get the disease. So for identical twins, it's between 84 to 100%, and for non-identical twins, it will be 20 to 35%. And studies suggest that chromosomes 1, 3, 6, and 15 are linked to dyslexia. And the scans of brains of dyslexics have shown a decreased activation of the visual word form area and the left temporal parietal and occipital temporal cortex. Dysgraphia. Dysgraphia is basically difficulty writing words instead of reading. So you have phonological, which means they're unable to sound out unfamiliar words and write them out, but if they already know the word, they can write it out. And then you have orthographic dysgraphia, which is they can sound out words but not imagine them visually. For example, they can write out regular words such as care or tree, but for irregular words such as half or busy, they might spell them like this. Now for dysgraphia, these are the areas of the brain that are affected. So for phonological, you have Broca's area, the ventral presentral gyrus, and the insula. And for orthographic, you have, again, the visual word form area. Right. For the extra info, I found a pretty interesting study. They found that reducing visual crowding can help people with developmental dyslexia, or DD as they called it. And they noticed that reading accuracy was improved among children with DD when the spaces in between words in a text were spaced further out, like this. They also did something that I thought was interesting. Like they made some of the children play a video game called Rayman Raving Rabbids for 80 minutes per day for 2 weeks. And I thought this was interesting that they were able to have higher reading accuracy and speed than the group that didn't play the game. So this can make it easier for dyslexic children to learn how to read and decrease anxiety about reading. You can find more about the article in this link, but all you have to do is log in, say that you're from ASU to get the full article. And yeah, that's pretty much it.